All right, so in class we covered this page here, these ones, and we were over in this last few examples. So let's think about this one here. So we have a log function, move to the left 5 and down 3. So you could put this on your calculator, but when you look at your calculator, you're not going to see everything you need to see necessarily. So think about your original log function. It's coming up through the point 1, 0, and it's raising up very slowly. It doesn't touch the y-axis, it does touch the x-axis. Right? Remember, this is going up, 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 up. So it doesn't matter if you move the graph up or down, it'll cross the x-axis somewhere. Because even if you move it down really far, this is still going to raise up, 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 all right, very slowly. So it's asking you about the x and the y-intercepts on this picture. So right now, it doesn't have a y-intercept, it only has an x-intercept. But the minute that I move it to the left, this whole graph is going to shift over, and then this part of the graph will be crossing the y-axis. So it's going to have both. So it's going to have one x-intercept, because this will end up crossing there, and one y-intercept. So letter D. So let's go ahead and graph it. So 1, 0 is going to move left 5 and down 3. My asymptote was at 0, so now it's going to be back 5, so it's me here. So when we go to graph this, it's going to look like this. We're going to see it cross the y-axis. So to cross the y-axis, I need the x value to be 0. So I could just plug in log 0 plus 5, so 5 minus 3. So there's going to be my y-intercept, negative 2.3. But what we're going to think is it's not going to go up high enough across the x-axis. But it will eventually, because this is going to keep raising and raising and raising, right? Or increasing and increasing. All right. So log, it's base 10, x plus 5, and then minus 3. Now let me say something about if it wasn't base 10. If you want to type in something that's not base 10, you press the math button, and you go down, and there's something called log base, and you choose that. And then you can put any base you want. Okay. So math, and then you go down. All right, but anyway, we have this one. Let's graph it. So remember that, this is raising. It's going to cross the x-axis. I see it cross the y-axis, and this keeps going down, even though the calculator can't show it. All right, so here, which number is a 0 of this problem? So you can do this one of two ways. You could go to the the graph and do that. Remember, a 0 is an x-intercept, and an x-intercept is when the y value is 0. So let me rewrite this. Log base 10, because it didn't say anything else. So based on these little equations that we did earlier, these little equations back on this page right here, you can actually solve this by hand. 10 to the 0 has to equal that expression. Well, 10 to the 0 is 1. So 1 has to equal 2x plus 2. All right, so if you take away 2, you get 2x equals negative 1. So my answer is negative 1/2. The other way to do it is to make a picture. 2x plus 2. And it's asking for the x-intercept. It looks like it's at 0, but I know it's not. So I'll do second calc, number 2, and I'll just tell it to start at like negative 1 and look all the way until it gets to positive 1. Look in that area there. And there it is, negative 0.5. So either way, you got your picture here. The asymptote is negative 1 because this graph is 2 parentheses x plus 1, like that's what this factors to. So negative 1 is my leftward motion. So Also, another way to tell where the asymptote is, if you look at the table, you see that's the first place it gives me an error. It gives me an error for everything past, for -1 back. Okay. Just like for the other problem, when I have log of x plus 5, and then -3, if I look at the table, everything from -5 back. So as long as the asymptote's at like an integer, you can look at that. Right here, what's a 0? So again, a 0 is the x-intercept. So let's do this one by hand. We looked at the picture, look at the graph already on this last one. So a 0, that's an x-intercept. It's where the y value is 0. So let's do that. Log of x plus 4 minus 2. We're setting it equal to 0. Okay. Now, I cannot do my 10 to the power stuff yet because this 2 needs to be on the other side. Like, it has to have the log all by itself. So I'll write log, I'm going to put base 10 of x plus 4 equals, I'm adding 2 to both sides, so it equals 2. All right, let me write that again. Log base 10 of x plus 4 equals 2. All right, so let's go ahead and do it. 10 to the 2 has to equal x plus 4. So that's 100 equals x plus 4. So x subtract 4 is 96. Now, you could do this on a picture, but the problem with doing it on your calculator is when you have this in here, log, x plus 4 minus 2, when you have it in there, you're like, oh, look, it's going to cross the x-axis, but where does it cross? And you have to change your window, keep going further on the x-axis, like let's go to 50. And it still doesn't touch the line. So you'd have to go all the way over to like 100 before you could see it and before you could ask the calculator with the second trace. So it's better to just do it by hand. All right, another thing you do, look at the table. And we want to know when it changes from negative to positive, because that would be an x-intercept when your graph changes from negative to positive. So, okay, so I can sit here all day, but I'm just going to do it a little bit higher. All right, so there I'm all the way at 90 now. So you see right there, look, 96 is where it goes, but it's going to take a while to figure that out. All right, so do your math. All right, so you guys have to do, on the next page, you got to do 1 through 9. So remember you're doing these 9 problems here, but you are not going to do this back page. So don't do that. No quiz next class, and I'll see you next time. No quiz. All right, bye.